Hi everyone. So hopefully you've managed to watch the video that I've set as the first task, showing Usain Bolt running 100 metres. Fantastic achievement. The next slide I want to show you, or what I want to talk about, is what the learning objectives are for today, and then I want to talk about that race. So bronze will be able to describe what an object is doing from its distance time graph. Silver is to be able to calculate speed from a distance time graph, and gold is to know how to calculate speed from a curved distance time graph. Now I know a lot of you have done this chapter before, chapter 9, because we've obviously just finished chapter 10, but it's coming towards the end of the year, and some of you might be coming into school and some of you might not. So Mr. Caldecott and myself thought it would be a good idea to go through some of this topic again, just as a bit of revision. So they're the learning objectives. So the reason I showed you the video of Usain Bolt running is because when you think about Usain Bolt running a race, his speed doesn't actually stay the same in the race. He changes speed. So initially he's not got any speed, and because he stopped, and then he will accelerate and his speed will get faster up to a maximum speed. And actually Usain Bolt then decelerates at the end of a race, or at the end of this race. So at any one point he will have a different speed, but his average speed will be the average over the whole race. And in order to calculate average speed, which is a bronze task, you would do the total distance divided by the total time. So in the video that you saw, the total distance was 100 metres, and then if you check on the timestamp, you divide it by the total time, it was 9.63 seconds. So because we've done the total distance divided by the total time, that will give us our average speed. So if you do that calculation, 100 divided by 9.63, you get about 10.4. So on average, Usain runs at about 10.4 metres per second. Some parts of the race is running slower than that, and because it's an average, in some parts of the race he's running faster than that. So average speed is equal to total distance divided by total time. Well, we're going to look at distance time graphs here. So here we've got a distance time graph. On the y-axis you've got distance, and on the x-axis you've got time. Time is going up in 10 seconds. We've got 10, 20, 30, 40, 50, and then distance is going up in 5 metres. You've got 5, 10, 15, 20. And I'm going to show you what's happening in each section. So the first section here, you've got a straight line moving up. This means that the car will be moving forward at a constant speed. So because the line is straight, it means a constant speed. To work out the speed from this, you can do a little calculation, which we'll do later. So I'm just going to show you this car will move 5 metres in 10 seconds. So on the graph below, well, on the little picture below, we've got 5 metres, 10 seconds. So I'll show you what that looks like with the car. It's obviously quite slow, but it's moving at a constant speed. What will happen then in this section, it's flat, so that will remain still. The distance is not changing for 10 seconds. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We then move on to the next part of the graph where again the distance is increasing with time, but this time the line is steeper. And as you saw the car, it moved faster because instead of moving 5 metres in 10 seconds, it has to move 15 metres. So from 5 to 20 is 15 metres in the same time, 10 seconds. What we then have is the downwards part of the graph. So in this section, the car is going to go back to distance 0 in 20 seconds. So from 30 to 50 seconds, 20 seconds, if we watch what happens. The car is then moving backwards, and it's going to move 20 metres in 15 metres Oh, sorry, 20 meters, yeah, in 20 seconds. 20 meters in 20 seconds. Again, it's a straight line, so it's a constant speed, and the steepness is between this one and this one, and so the speed will be between those. So I'll show that happening in one go again. So we start right at the start, constant speed, moving forwards to 5 meters in 10 seconds, stationary for 10 seconds, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, then moves forward at a faster speed, covering 15 meters in 10 seconds, and then moves backwards at an in between the first and second speed, moving 20 meters in 20 seconds. So for a bronze task, you need to be able to look at a graph like this and be able to say what's happening in each section. So if we look at the graph again, the first part is a straight diagonal line. This means it's moving forwards with a constant speed. A horizontal line means the object has stopped. A steeper diagonal line means it's still moving forwards with a constant speed, but it's steeper, so it's faster than before. And then a diagonal line downwards means the object is moving backwards with a constant speed. It would be good for you to draw this and then add the labels. The silver task, a little bit harder, would be then using a distance time graph. If you work out the gradient of the slope, you'll find the speed. So in maths, you'll know from maths that the gradient is the change in y over the change in x. What you have to do is take each section at a time. So if we look at section 1, this is section 1 here, we're going to do how much does it go up divided by how much it goes across. So if we look, it goes up from 0 to 5. Okay, so our top number is going to be 5, and we're going to divide it by how far it goes across. So it goes from 0 across here, which is 10. So we're going to do 5 divided by 10, and that gives us a speed of 0.5 meters per second. That means that every meter covered takes half a second. Okay? Or in 1 second, half a meter is covered. In section 2, which is this one, we do the change in y. Now it starts and ends at 5 meters, so that means the change in y, the change in the distance, is 0. So we're going to do 0 divided by the change in x. So it goes from 10 to 20. So the difference between those two numbers is 10. So it's 0 divided by 10, which is 0 meters per second. And we know that because it's stopped, or it's stationary. Stationary is another word for stopped. In section 3 here, in our steep line, our change in y, so we're going from 5 meters up to 20. So the difference between 5 and 20 is 15, and you can count that going up. 5, 10, 15. So we're going to do 15 divided by how long that took, and it's gone from 20 seconds to 30 seconds. And actually you can see in my calculation I've made a mistake, so I'm just going to correct that. It actually took 10 seconds. So we're going to do 15 divided by 10, which makes 1.5. So you can see change in y is 15, change in x is 10. 15 divided by 10 is 1.5. For the backwards part, again, the change in y, so you're going right from the top all the way to the bottom. Okay. So it's from 20 to 0, that's 20 meters. And how long does that take? So this one's a bit different. Instead of divided by 10, it's taken longer. It's taken 20 seconds. We've got 10, then 20. Okay, so that makes 1 meter per second. So it'd probably be good for you to pause the video here and take a note of this. Change in y divided by the change in x is called the gradient. It just tells you how steep the line is. And the gradient of a distance time graph tells you speed. So for the silver award, I want you to plot this graph and work out the speed for each section. So you've got the sections here, 0, A, B, C, D, E, F, G. So basically, plot this graph, okay, and add the points to it. It's, for the distance, if you go up, you've got to go up to 70, so you may as well go up in 10. So 0, 10, 20, 30, 40, 50, 60, 70. And the time goes up to 70. Oh, sorry, it goes up to 80. So you'll go up to 80 here. And the time goes up to 70, so go up in 10s again. 10, 20, 30, 40, 50, 60, 70. Then you just plot the points. So you've got 0, 0 is the first point. So that'll be, and then label that O. The next point will be 15, 10 on the time, so go across to 10 and then up to 15 on the distance, okay? And then put a cross for that point and then label it A. Then the next point will be 20 on the time, so go along to 20 and then up to 30. Put a cross and label it B, okay? And what I want you to do is work out the speed for each section. If you press pause now and do it, on the next slide are the answers. But you should have a go yourself and then see if the answers are right, because it doesn't matter if you get it right or wrong. All that matters is that you've learned from it. So if you do it and you get messed up or you make a mistake, that's fine, because then you can just check it on the next slide. So these are the answers. So here's my graph. You can see I've labelled every point O, A, B, C, D, E, F and G. Okay, and then here I've done the change in Y divided by the change in X for each one. And those are your answers. Okay, so you can check those. The very last part is for gold. It's only on the higher tier, and it's if you plot a graph of distance against time for an accelerating object, the graph becomes curved. So basically, if it's accelerating, it means its speed is changing, so you don't get a nice straight line. So how do you work out the velocity? So what you need to do is draw a tangent to the line and work out the gradient of the tangent. So I'm sure you've learnt this in maths, but if you draw a tangent to the line, I've drawn one here. It's a line that just touches the curve at the point you want to look at. Okay? So whatever time you're told to look at, you draw a tangent to the line. So it's a line that's here, and it just touches the point, and it follows that curve at that point. You then do the change in Y divided by the change in X for that triangle. So change in Y divided by the change in X here. Now this would only be at the very end of the question. It would be only worth a few marks in the whole question. There is one in the gold task on the question. So it'd be good if you were in a higher set to have a go at that. Even if you get it wrong, again, it's all about the learning. So what do I want you to do? So so I want you to take notes from the slides. There is a set of questions. So you only have to do one question, bronze, silver or gold. It would be good if you're in one of the higher sets to start with gold, and if you struggle, move down to silver. And again, if you're in a middle set, it would be good to maybe start with silver and work down to bronze if you get stuck. Or if you find it too easy, go up to gold. If you're in a bottom set, you might feel more confident at starting with bronze, having a go. And if you find that you find that okay, then have a go at silver. I'm sure your teacher would be really happy to see you having a go at that. So the expectation is that you do one question, bronze, silver or gold. But if it's too easy or too hard, it's fine to change which one you're going to do. If you have any questions whatsoever, please email your physics teacher and they will be able to explain to you in more detail. I hope you enjoyed doing this work and I look forward to marking it. Thank you.